Radiation is the process by which vibrating electrons, molecules, or other charged objects release energy in the form of electromagnetic waves. When you heat up something and it glows, that's because of radiation.
Anytime a charged particle, like an electron or molecule, accelerates, it creates electromagnetic radiation. One way to regularly accelerate is to oscillate it like so. So that electron in that antenna, as it accelerates or oscillates up and down, it releases electromagnetic radiation. This is why things glow when you heat them up. The particles are oscillating, they are composed of charges, and thus they are creating electromagnetic waves.
Now, you don't actually have to know this equation. What you have to understand is what qualitatively affects how much radiation is given off. P is power. It's, again, the rate of electromagnetic energy emission. It is in watts.
Sigma
is a constant, okay? So we don't even have to worry about this constant qualitatively. Notice that if you have more surface area, you give off energy at a greater rate because there's more exposed area to give off energy. Which is brighter? A star that is a giant star at temperature 5,000 Kelvin or a small star at temperature 5,000 Kelvin? Which is brighter? The giant star just got a bigger area that's emitting radiation.
Surface area affects the rate of thermal radiation.
Emissivity, that is a constant that it depends on the material. That's kind of like the thermal conductivity constant. It depends on the material. The more emissivity, the more energy it will give off, but also the more energy it will absorb. If the emissivity is 1, it will absorb all the energy radiated on it. What has a higher emissivity? A black object or a white object? 1 for black, 2 for white. Which has a higher emissivity? The best way to think about it, that is, which will absorb more energy? The black object. In fact, a black body will absorb all the energy that you shine at it. What's a black body? If you have a box with a hole in it, shine a flashlight in there, no light comes back out. That's a black body.
A black body is not only a perfect absorber of electromagnetic radiation, it's also a perfect emitter of electromagnetic radiation with an emissivity of 1. The sun approximates a black body in this regard.
So surface area affects it. The emissivity constant, that can only be between 0 and 1. The temperature difference, notice that it's to the 4th power. If you have a this is the temperature of the hot object, and this could be called the temperature of the cold object or the surroundings. So the bigger the temperature difference between the object and its surroundings also affects, just like for a thermal conductivity, affects the rate of transfer. And by the way, these T's, they are to the 4th power right there. But again, you don't have to know any of these equations. You just got to understand conceptually what factors might affect it.